Hello everyone, welcome you all again to the third lecture of Foundation Engineering. In this lecture, I will cover the basic load transfer mechanism of file foundation. I am Dr. Shobik Patro, Assistant Professor in the Department of Civil Engineering, Swami Vivekananda Institute of Science and Technology, Kolkata. And in this series of lectures, I will cover all the modules as per the MACOUT syllabus for your preparation of your examination. And these videos are basically prepared as a part of the Mission Career Initiative by Swami Vivekananda Institute of Science and Technology. Now, if we before proceeding to the load transfer mechanism of pile foundation, first we need to understand that what are the loads are basically acting on the pile. There are three kinds of loads generally act on the pile. The first one is the axial or vertical load. That's mean if I install a pile on the site and directly the load is coming from the superstructure as a vertically downward, it is known as your axial load. If the load is acting in the lateral direction, that is known as a horizontal load or the lateral load. And the example of this kind of load are basically wind forces, earthquake and wave forces. And if the load coming up from the superstructure acting in an eccentric manner, then moment will generate in the pile, then it will be known as your moment load. Now the when a compressive load, basically the load transfer mechanism of pile can be categorized with mainly three mechanisms, that is the end bearing mechanism, skin friction mechanism, and the combined effect of skin friction and your end bearing mechanism. Now we can say that this is a pile, this is my ground level, and the load from the structure is coming vertical superstructure is Q. So if the load is transferred to the hard stratum directly, that's mean at the tip of the pile there is a hard stratum of rock is present. So the vertical load will completely transfer to the rock stratum. Then it will be known as your end bearing mechanism. If this rock stratum is present at the far depth below the tip of the pile, like in this situation, and the rock stratum is present below far depth from the tip of the pile, this is the tip of the pile, then in this case, when the pile is penetrating inside the soil, then a frictional resistance will develop in between the surface of the pile and the surrounding soil. So this is known as your frictional resistance or the skin friction. So the load will transfer, the vertical load coming from the superstructure will transfer to the soil by this skin friction resistance. So this is known as your skin friction mechanism. Now, if we combine both the skin friction mechanism and end bearing mechanism, then we call it a combined effect of end bearing and skin friction mechanism, and it is the most practical solution for structure, and because we are optimizing the bearing capacity or the resistance provided by the soil, that's mean we are using the skin friction resistance as well as we are using the end bearing resistance. So suppose in this case where a vertical load Q is coming from the superstructure, this is your pile cap, and when a compressive load is applied at the top of the pile will have a tendency to go downward. Now relative to the surrounding soil. Now that means suppose this is my initial condition. Now if it is go downward, then some displacement will occur. So due to this displacement or the downward displacement, this cause a shear stress to develop between the soil and the surface of the pile. Suppose here the soil is present and this is the surface of the pile. So in between there is a frictional resistance will develop. Now the applied load is distributed friction load along a certain length of the pile measured from the top of the pile. Now the friction load distribution will extend more and more towards the tip of the pile. That's mean as we know that it will downward. So the horizontal force or the lateral pressure acting on the pile will be much more higher in the tip. That's mean if we consider the earth pressure distribution. So this is generally the distribution of the earth pressure at the top of the or the near the ground level surface. The lateral force is lesser, and at the as we go beyond certain depth, then the lateral force will increase. So in this case, the resistance will also increase in such cases, because when the pile is going to penetrate inside, so as the lateral force is higher here, so in this case the resistance will develop much more higher, I mean compared to the surface of the or the near to the ground surface. Now, so this is known as the your skin friction. Now, when the load of the pile, suppose this Q is coming and the Q is much greater than the QF. So after a certain load amount, suppose Q1, the when it will be equals to QF, after that the skin friction will not take any additional load. That means it will not transfer the load to the subsoil. In this case, or in such situation, the end bearing resistance will come into play. The additional load will be taken by the end bearing. So if we say that the Q2, the total load Q is combination of Q1 and Q2, and Q1 is taken by the skin frictional resistance, and the additional resistance that required to sustain the load coming from the superstructure will be resisted by the base resistance, and that is known as your QB. So this total load Q will be distributed in such a manner that QF plus QB. So first, always the QF will act. So when the load is transferring through the pile, first initially the QF will act. Now when the QF will reach its ultimate point, that the no additional skin friction resistance is not providing, after that the end bearing portion will active and the load will be transferred in such a manner. So we can say that the ultimate load carrying capacity of pile can be combination of the end bearing resistance and the frictional resistance. So that is the basic mechanism of load transfer for pile foundation. So this is the end of your lecture 3. Thank you.